Imagine a world where the biggest insects are bigger than seagulls, where dragonflies have a wingspan of 3 feet, and cockroaches are over a meter long. It sounds crazy, but that was reality for around 40 million years during the Carboniferous period. Today, we're going to travel back in time to meet some of the giant bugs that ruled the planet before the dinosaurs. Insects are the most numerous animals on land today, but they usually stay small because there isn't much oxygen in the air for them to breathe. The average insect is only about half an inch long. But that hasn't always been the case. During the Carboniferous, which lasted from 360 to 299 million years ago, the air had around 35% oxygen compared with the current 21%. It was also colder at the poles and there were no large land predators. This created the perfect conditions for creepy crawlies to grow big. And boy, did they ever! So what exactly was the Carboniferous period? The name itself means Great Coal Age. It was part of the Paleozoic era, which means ancient life. The Paleozoic is divided into 6 periods, and the last one was the Permian, which included the largest mass extinction event in Earth's history. The animal kingdom was never quite the same after that. It's hard to imagine how big insects could get without being able to fly, but it was the ability to fly that actually caused their gigantism. The ancestors of modern insects crawled out of the water and onto land some 390 million years ago. They quickly developed the ability to fly, and this allowed them to find new food sources and escape predators. Being big helped them survive. In this brand new environment, small insects would be picked off by amphibians, reptiles, and early mammals, so only the big ones survived. There wasn't much competition for resources either, so these giant insects flourished. We don't know exactly why the oxygen levels were so high during the Carboniferous, but scientists believe that more trees and plants led to more oxygen being produced. Another theory is that the higher oxygen levels were the result of volcanic activity releasing gases trapped inside the Earth's crust. Whatever the reason, these oxygen-rich conditions allowed insects to thrive. But why do insects need so much oxygen? The answer lies in their small size. Their bodies have a lot of surface area compared with their volume, so they lose water fast. To avoid drying out, they need to keep their body processes running at top speed. The only way to do this is with a lot of oxygen. However, this need for lots of oxygen makes it difficult for insects to get bigger. As an insect grows, its volume increases faster than its surface area. This means that if an insect wanted to get bigger, it would dry out much faster than it could get the oxygen it needed. But the conditions during the Carboniferous were different. There was so much oxygen in the air that this problem didn't exist. So insects could keep growing. These giants weren't just dragonflies and cockroaches. There were also giant beetles. Some of them were almost 7 inches long. The biggest of all was Meganora. These giant insects were like today's mayflies, but they were 10 times larger. If one landed on you, you wouldn't be able to brush it away. You'd have to wait until it flew off on its own. And that may take a while since their wings were huge. The biggest ones had a wingspan of 3 feet. That's the size of a doorway. The only way an insect could evolve to be that big is if it had huge wings. This allowed it to glide rather than fly. Scientists think they may have used their big wings to control their descent so they could eat aquatic insects at the surface of the water. Speaking of giant insects with huge wings, let's look at griffin insects. They lived on all continents and were the dominant predator of the Carboniferous. They looked a bit like praying mantises, but they were massive. One species called Meganora only had huge jaws and eyes like saucers. The adults were about 3 feet long and ate anything smaller than them, including each other's young. Even though they were so big, they probably couldn't fly very well. They had to flap their wings really hard to get off the ground and make short, slow flights. But once they were up in the air, they were too big and heavy to be very maneuverable. This made it easier for other giant flying insects like the dragonflies to catch them for dinner. And then there were the cockroaches. Oh yes, the cockroaches. They were even bigger than the dragonflies. These supersized roaches had long, spiny legs and bodies over a meter long. They lived in warm climates and probably ate plants. Not all the insects during the Carboniferous were so huge. Stick insects were small and mostly brown, although there was one exception. The giant stick insect called Phobactis chani was over 2 feet long. It was the king of camouflage. But that didn't stop it from becoming extinct along with all the other giant insects at the end of the Carboniferous. Scientists aren't sure why the giant bugs went extinct, but they have a few theories. One idea is that the amount of oxygen in the atmosphere decreased. This would have made it harder for them to get the oxygen they needed to survive. It's also possible that the continents moved and the climate changed. If this happened, many of the big insects would have died off as the temperature dropped and the food supply dwindled. Another theory is that something else caused the mass extinction at the end of the Carboniferous, like a giant asteroid impact. This would have triggered a chain reaction that wiped out most of the giant bugs. Whatever the reason, the death of these giant insects marked the beginning of a new era. The oxygen levels never went back up to the Carboniferous heights, and there was now a food supply of coal for early humans to use. Could this mean that the giant insects sacrificed themselves so that we could have the energy we needed to advance? Maybe. But whether or not that's true, we should be grateful that we never had to share the planet with 3-foot-long cockroaches. If you enjoyed this episode, don't forget to subscribe so you never miss an upload. That's 1 minute. See you tomorrow.